We're going to talk about where did analytics come from? Is it something new, or is it a new name for the good old-fashioned computerized decision support systems? And we will look at a simple taxonomy of analytics, kind of to put some structure on what is analytics, what are the different types of analytics, and how do they relate to one another. This is a graphical depiction of the longitudinal view of analytics. Is analytics new? Where did it started? And then this graphic also nicely captures the transition of different names in the context of analytics, starting from 1970s all the way to 2010 and beyond. But probably we need to go prior to 1970s to find the foundations of early implementation of analytics, or I'm going to call it here computerized decision support systems. Now, if you go all the way back to 1940s, when there was a need to make more out of the limited resources, basically need pushed towards the innovation, we developed the very foundation of prescriptive analytics, the operations research methods, the optimization and simulation methods, where the application of those methods generated significant output, optimizing the use of the resources, both raw materials as well as human resources, to produce the outcomes that help the viability of the nations in 1940s. So since then, a lot of terminology have changed, but early implementation of analytics relied upon the expert knowledge, expert opinions, mathematical formulations, as opposed to collected data. So because of that, we call them operations research and prescriptive analytics applications. But the data emerged in 1970s. And those data sources generated routine reports for managerial practices. Routine reports could be daily, weekly, or monthly, depending upon what the report is all about. Every managerial level, every manager role type would actually receive routine reports to see what happened. And based on what happened, they have to project to see what should happen and how they can influence the happening of things in the near future. During that time period, 1970s, we also experienced inclusion of artificial intelligence and expert systems into managerial decision-making. Idea there was to capture the reasoning process of experts and then represent that problem-solving cognitive system in a computer so that you can replicate it and distribute it throughout the organization so that people using the system can act like an expert because of the advice that they receive from the computerized expert systems, all of which we call them at that time period decision support systems. Then in the 1980s, we moved into relational database management systems because a lot of the functions within the organization built their own databases, and then merging of the databases was needed to create on-demand reporting for better managerial decision-making. It kind of led to this integrated enterprise systems. Actually, it should be called integrated enterprise systems for information collection and dissemination, ERP systems, that laid the foundation for those on-demand, still static reporting for managerial functions. In 1990, there was a separation between transactional databases and the databases that serves the needs for the decision makers, the knowledge extraction databases. We call them data warehouse. So transaction databases, multiple of them, can feed into a central repository called data warehouse, which is exclusively used to generate actionable insight and knowledge for decision makers to make faster, better decisions. Data warehouse established the foundation for dashboards and scorecards, some graphical illustrations of how organization is doing at different metrics, and by doing so, helping decision makers to be proactive. about problems and opportunities and take advantage of them. Those systems serve the needs of the executives, and that's why they called executive information systems. Mostly graphical, and a single computer screen, dials and gauges, in color coding on those dials and gauges that shows how the organization is doing in key performance indicators. Leading towards 2000s, we see emergence of cloud computing, software as a service phenomena to make analytics, or the business intelligence is what we used to call it during that time period, approachable to organizations that are small to medium in size and does not have the financial means to actually build their own infrastructure. So cloud computing helped expand the horizon for business intelligence usage. We'll talk about business intelligence and compare that to analytics in a few minutes, but the idea here is that all those dashboards, scorecards, and data warehousing kind of encapsulated themselves into this decision environment, and the new name was coined as business intelligence. Those systems started as descriptive analytics, looking at what happened graphically and in a time series fashion, showing how things are progressing, but also included data mining, text mining type knowledge extraction processes in them. In 2010 and beyond, we see big data analytics. We see on the hardware side, in memory, in database, and a lot of big data related technologies like Hadoop, MapReduce, which again, we're going to talk about in this live lesson. Also, we see inclusion of soft data. Data that comes from social networks, social media, discussion boards, internet in general, that helps organizations to understand holistically how they're doing, what they're doing, and how they can do it in a better fashion. So basically, in summary, the name has changed, but the fundamental idea of converting data and experience into actionable insight has not changed. The comprehensive nature of how we do it has changed, but again, the goal of making better, faster decision has not changed. Here is a simple taxonomy for analytics. It takes business analytics and splits it into 3 echelons: descriptive, predictive, and prescriptive. And these 3 echelons feed off of each other. Descriptive is like a rear view mirror that looks at what happened, what is happening. And to be able to do that, the enablers would be the reporting, the dashboards, the scorecards, all of which are laid upon a well-structured data warehouse. And the outcomes would be well-defined business problems and opportunities encapsulated into business reports. It is valuable. It is what we have been doing for quite a long time. The next echelon, once you mature out of descriptive, you kind of move into predictive. As opposed to looking backward, now you're looking forward. As opposed to answering the question, what happened? Now you're answering the question, or trying to answer the question, what is more likely to happen? Why will it happen? And then to be able to do that, your enablers are data mining, text mining, time series forecasting, web, multimedia mining, all of which collectively will help you have this future projection of what is about to happen. So the outcome is the accurate projections of the future states and conditions so that you would understand what's about to happen. The top echelon is called prescriptive analytics, which takes advantage of what happened, what will happen, and then helps you decide, what should I do now that I know what happened, now that I know what will happen? What do I do with that information? How can I make the best out of that information to optimize the outcome of my business transactions, business processes? So idea here is to figure out what is the optimal decisions that you can make based on the information produced by the descriptive and predictive analytics methods. So enablers here are the optimization, simulation, multi-criteria decision-making models, as well as expert systems. And the outcome would be the best possible business decision that you can make and should make at that point in time to influence your business transactions in a positive way. Now, the first echelon, descriptive, we have been calling it business intelligence for the last 10, 15 years. Okay, that's where we spent a good part of analytics in the last 20 years. The name was coined by industry, specifically by Gartner Group, one of the well-known business consultancy group, as business intelligence, and it has been around as a popular term for at least 10, 15 years. Nowadays, business intelligence term is migrating into analytics and advanced analytics as opposed to talking about what happened. We're more focused on advanced analytics and want to talk about what will happen and what should I do about it. How can I take advantage of those problems that I foresee or the opportunities that will present itself before my competitor do. So what is the optimal course of action? And that's why we call the predictive and prescriptive at this point in time as advanced analytics. Here are the variations of the analytics, kind of textually described. It is descriptive, it's predictive, it's prescriptive, but it kind of moves, again, it builds upon each other. So what's the next layer? Tom Davenport, for those of you who have been reading analytics literature, knows this name. He is one of the well-known speakers, visionaries in the world of analytics, came up with this next layer that he calls it automated analytics. So now that we have the descriptive, predictive, prescriptive, how can we encapsulate it, automate it in such a way that most of the decisions can be made automatically without human involvement, human bias, and judgment involved in the process? We're kind of moving towards that. We have accomplished in certain aspects of business the full automated execution, but not every aspect of business is there yet. But it is moving towards that way. Here's another graphic coming from the Real World Data Mining book, where it takes the descriptive analytics, predictive analytics, and prescriptive analytics and puts it into a continuum of degree of analytics sophistication. So every organization starts with descriptive analytics, where they answer what happened, why did it happen, how am I doing. Both past and present is captured based on the data that's generated and pushed into the organizational databases, kind of leading towards predictive analytics. What else is most likely to happen? What's the chances of it happening? How can I take that into account to minimize my risk and maximize my outcome? And for doing so, you're using techniques like text mining, data mining, forecasting, and statistical analysis. The prescriptive analytics, again, is all about how can the best be realized? How can I achieve the best possible outcome? What do I do and how can I do it? One way to actually do that is to use optimization modeling. Optimization modeling applies to a certain class of problems, the problems that cannot be optimally analyzed. We need to use simulation. We need to use heuristic methods, where as opposed to optimal solution, we end up generating a good enough, satisfying solution because the problem is too complex to find an optimal solution for it. So it's also called a multi-criteria decision making, because most decision situations do not have a single criteria to optimize. There are multiple criteria, and the bad thing is that some of those criteria pull in different directions, opposite directions, and finding an optimal point where all the objectives can be optimized is a difficult, challenging, yet doable task if you are using mathematical extend prescriptive analytics to do so.